Hello guys, welcome to the portal. Okay, now let's continue with our video. Let's continue from the last video, which was the introduction to organic reactions. So now let's look at the combustion reactions of alkanes, alkenes, and alkynes. Let's start with alkanes. Okay, so now for alkanes, we have to have the formula of alkanes, the general formula of alkanes, right, of the homologous series of alkanes. So there it is. Okay, so let's take examples. So the type of question that you will expect from this kind of reaction is for you to balance the reaction, right? You have done this in your grade 10, okay, but I understand that in grade 10 you guys were dealing with the issue of COVID and stuff, so hence I want to emphasize some things because some of you may be struggling to balance reactions. Okay, let's start. Let's say now, let's start with a methane. Methane is CH4, right? So this is our example. This is example 1. Okay, it's CH4 plus O2 plus carbon dioxide plus water. Okay, note this, you don't have to balance the heat, okay, but you just have to write it in the end. Okay, so now we are asked to balance this equation. Okay, so how do we balance this equation? We have guidelines that you can use to balance this equation. First of all, you have to number one, you have to balance the number of carbons. Balance number of carbons. Okay. Number 2, balance number of hydrogens. Number 3, the obvious one, you balance number of oxygens. Okay, and I have noticed that learners make a mistake. They make a mistake of not differentiating between O2 and an O. So these two things are these are two different things, guys. An O2 is a molecule, is an oxygen molecule. When I just say O, I'm saying number of atoms of oxygen. I'm not saying number of O2s. I'm saying number of O's. Okay. So now, solution. Let's get our solution. Okay. So let's start by balancing number of carbons. Okay. Now, if I can check on the left, I have 1 carbon. On the right, I have 1 carbon. So I can say my carbons, they are balanced. Okay. So on the left is what? 1 carbon. On the right, 1 carbon. Okay. So let's go to hydrogens. On the left, I have how many hydrogens? I have 4 hydrogens. 4 hydrogens. On the right, I have what? I have 2. Okay. In order for me to get 4, I'm sorry, to get 4, here I have 2. So it means I must put 2 here and have 2 times 2 and have what? And have 4. Okay. So now I must have 4. Okay. And then what about oxygens? Oxygens on the left I have 2, even on the right I have 2. So the only place where I will balance is on the water molecule. Okay, guys. So when I've balanced, I must have 4 hydrogens as well. Then in here I must have 2 oxygens, and also in here 2 oxygens. So my equation is going to be CH4 plus O2 giving carbon dioxide plus 2 water molecules, okay, plus heat, okay, plus heat. So heat is given off. I prefer that you write it as plus plus change in H is less than 0 to show that heat is given off, plus change in H less than 0, then you show that heat is given off. So you get 3 marks, okay, from this. You get 3 marks. You've balanced your water there. Then they also 1 mark to the carbon and 1 mark to the oxygen. Okay, this was an easy one. Okay, example 2. Let's try something that is a bit complex. Okay, so we are still under combustion of alkanes. Let's say example 2. They say balance the reaction below. So now let's say they've given you a propane, okay, a propane. So they want you to balance the propane. We know that here is going to be plus, change in H less than 0. Okay, so now as I've said from the previous page, that we have to first balance our carbons. Okay, we have to balance our carbons first. Okay, so now let's try to do that. How many carbons? I will choose a red color for the carbons. Okay, let's first balance the carbons. Here I have 3 carbons, and in here I have 1 carbon. So it means I must have 3 carbons. 3 carbons. Okay, so let's balance our hydrogens with green. Okay, so how many hydrogens do I have? I have 8 on the left. Here I have what? I have 2 hydrogens. So I can put 4. So 4 times 2 is 8. Okay, so I have 8 on the right, 8 on the left. So the only thing that is left is the oxygen. So how do I balance the oxygen? I look at the right side first before I go to the left hand side. So on the right hand side, if you can check, I have here 3 times 2. I have 3 times 2. I have 3 times 2. The 2 is white. I have 3 times 2. Okay, so meaning how many oxygens do I have? I have 6 oxygens. Okay, so here I have 4 times 1, and then in here I have 4 times 1. I have 4 times 1 oxygen. The 1 is white. Okay, it's just going to waste time. Okay, 4 times 1 oxygen is what? It's 4 oxygens. Okay, so in total I have 6 plus 4, which is 10. I have 10 oxygens. Okay, I have 10 oxygens. So 10 on the right, and then here I must have 10 as well. Let's put blue. No, it's purple. Okay, so I must put 5 here. So now I have 5 times 2, which is 10. Even in here I have 3 times 2, which is 6, plus 4 times 1, which is 10. So I have 10 on the right, 10 on the left. So I have 10 oxygens. Even in here I have 10 oxygens. 3 carbons, 3 carbons. Hydrogens, what about hydrogens? 8 hydrogens, 8 hydrogens. So our equation is balanced. Okay, so now we can say we're getting our 3 marks. 1, 2, 3. Okay, so that's all there is to it. So let me give you an exercise. A nice exercise. So you will balance number 1. You balance this C4 H10 plus carbon dioxide plus oxygen, plus oxygen giving carbon dioxide plus water plus heat. Okay, so now you are going to balance that, right? Number 2, balance for me, if I say balance C8H H18 plus water, okay, plus heat. So you can pause the video and attempt these problems. Okay, so now there's a way, an easier way that you will use, that I will show you to use in order to balance equations of combustion of alkanes. This equation applies to alkanes only. Okay, guys, so it applies to alkanes only. So now let me scroll and do the solutions and write the solutions. Okay, so now number 1, for number 1, so first of all I have to check carbons that they are balanced. Okay, and then again I have to check hydrogens, and then I also have to check oxygens. So okay, so there's this formula that if I can give you this formula, yeah, you will be able to solve any alkane with it. Okay, the formula says Cn H2n plus 2 plus 3n plus 1 over 2 O2 giving n carbon dioxide plus n plus 1 water, okay, plus heat. Okay, so let's use this equation to try and balance number one. All right, so whereby here n is our number of carbons. Okay, n is number of carbons. So number one, let's do number one. Number one, how many carbons do we have from exercise number one? We have 4 carbons, right? So we have 4, and then 4 times 2 is 8. 8 plus 2 is 10. Okay, so plus into, okay, now 3n plus 1. 3n plus 1. Now we have 3 into 4 plus 1 all over 2. Okay, O2. Okay, giving, remember n, how much is n? N is 4. 4 CO2 plus into 4 plus 1 water. Okay, so this gives us what? Here I have 3 times 4, which is 12. 12 plus 1, how much is 12 plus 1? Is 13. So here I have 13 over 2 O2. In here I have 4 CO2 plus 5 water molecules. Okay, so notice that we don't want to have fractions in our balanced equation. So here we must multiply out everything by 2. Okay, because here I have divided by 2, there's a divisor of 2, so I must multiply everything by 2. So if I multiply everything by 2, so it means that I'm going to have 2 C4 H10 plus 13 O2 giving 3, what was it, 3? No, it's 4, giving 4 carbon dioxide plus we had oh, because we have multiplied everything by 2, so this has to be, it has to be 8. It's no longer 4, it has to be 8. This has to be 8. Okay, so this has to be 8, and then here we had 5, so now it has to be 10 water. 10 water. So now if you can check, we have in here we have 8 carbons, 8 carbons in here, 20 hydrogens, 20 hydrogens in here, because 10 times 2, 20. 26 oxygens, 13 times 2, 26, and in here 8 times 2 is what? Is 16. 16 plus 10, 26. So 26 oxygen. So our equation is balanced without having the hassle of saying, hey, this one we balance carbon first, hydrogen second, and oxygen last. Okay, so you can see that we can balance these equations using a formula. Note this, guys, this formula only applies to alkanes. Okay, don't use it to alkenes. So now, what was our second problem? Our second problem was let's see, it was C8H18. Okay, so this equation is used for such problems whereby you have a lot of number of carbons. So C18H18. Okay, so now C18H18, no, not C18, C8. Okay, C8H18. 18. All right. So plus, remember on the formula it says 3n plus 1 over 2. So it's 3 into 8 plus 1 divided by 2. Then there's oxygen giving n of carbon dioxide. N is what this number of carbon. So it's 8 of carbon dioxide, right? Plus n plus 1 of water. What is n? N is 8. 8 plus 1 of water molecules. Okay? So now how much? What do we have here? We have C8H18 plus 3 3 times 8. How much is 3 times 8? 24. Okay, we have 24 plus 1, 25. Okay, 25 divided by 2 oxygens, giving us 8 carbon dioxides plus 9 water molecules. Okay, plus our heat there. So now we don't want fractions on our equation. So because we don't want fraction, just do this. Don't include the heat. Just do this. We multiply by 2. Okay, everything multiply by 2. So if this we multiply by 2, it will be 2C8H18 plus 2 multiplied by 1 over 2 is 1. So here I have 25 O2, giving us 8 times 2, 16 carbon dioxide. 16 carbon dioxide plus 9 times 2, 18 water molecules. Okay, plus heat. So now let's check if our things are balanced. So now in here I have 2 times 8 on the left. 2 times 8 is what? Is 16 carbons, right? Also on the right I have 16 carbons. Okay, and then what about hydrogens? Hydrogens, 2 times 18 is what? It's 36. 36 hydrogens. Okay, what about here? 18 times 2, still the same thing, 36 hydrogens. What about oxygens? I have 25 times 2, 50 oxygens. In here I have 16 times 2, which is 32. 32 plus 18, which is 50. 50 oxygens. So it works. Our formula works. So please guys, memorize this formula. Know it by your heart. In English they say know it by your heart. In our African languages we say it's a begahlo. Yes, or know it by your head. So now we can go to balancing alkenes and alkynes. Okay, so I won't do many examples in alkenes and alkynes. I'll just do few examples. So combustion of alkenes, right? We know that alkenes is CnH2n, right? So now it will be plus O2, giving us carbon dioxide plus water. Okay, also energy is released as heat. Okay guys, so now let's give an example. Let me give an example. Okay, so now check this one. Still same thing, you balance carbons first, hydrogen second, and oxygens the last. So here we have 2 carbons. So let me change my color here. Okay, 2 carbons, 2 carbons. Okay, what about hydrogens? 4 hydrogens, and then here I have 2 hydrogens, so it means I must put 2 here, so that 2 times 4, 2 times 2 is 4. Okay, so now before I balance this oxygen, I must check the number of oxygens on the right, because I've put my stoichiometric coefficients. So now here I have 2 times 2, which is 4, okay, plus 2. So 4 plus 2 is 6. Okay, so it means here I must put 3. So that if I count oxygens, I have 3 times 2, which is 6 oxygens. And then if I count carbons, I have 2 carbons, also what, hydrogens. What about hydrogens? Hydrogens, 4, and then 2 times 2, it's 4. So now everything checks out. 4 oxygens, right? Okay, so with alkenes there isn't much problems as well, so you can do another exercise, but I'm not going to give you a solution. You can check this one. C4H8 plus O2 . Okay, you can check this one as well. So it's not a problem balancing this one, because here we have an you know, C4 and H8. It's just number of H is twice the number of carbon, so it's not that much of a problem, guys. Okay, so it's like if I put 4 here, and then I have 4 carbons, 4 carbons. So if I put in hydrogens, I check hydrogens, I have 8 here, I just put 4. So, and then now 4 times 2 is 8, and then 8 plus 2, 8 plus 4, I mean 8 plus 4 is 12. Okay, so if it's 12 here, I just put what? I put 6. So I have 6 oxygens, 12 oxygens on the left, 12 oxygens on the right, 4 carbons, 4 carbons. What about hydrogens? 8 hydrogens, 8 hydrogens. So this one is not much of a problem as well. So let's go to alkynes. Alkynes. So alkynes, we have Cn H2n minus 2 plus oxygen, giving us carbon dioxide plus water. Also energy is released as heat. Okay, so now here, let's say you having a 2 carbons alkene, excuse me, alkyne, 2 carbons alkyne. So you have C2H, so it will be 2 times 2, 2 times 2, which is 4, 4 minus 2 is 2. Okay, so plus oxygen, giving us carbon dioxide plus water. Okay, so let's try to balance this. So how many carbons do we have on the left? we have 2 carbons. Let's try to put 2 here. Okay, and then how many hydrogens do we have on the left? We have 2 hydrogens, right? Having 2 hydrogens. So, and then here if I say, okay, I have 2 hydrogens as well, then here I have what? 2 times 2, which is what? 4. 4 plus 1 is 5. So this, remember that already this is on a multiple of 2. This will never be 5, okay? Because this can never be 5. It means that I must have even numbers when it comes to carbon dioxide and water. Always, even in alkenes and alkanes, if you want to balance your O2 on the left, on the right you must have even numbers of stoichiometric ratios. So now it means that this 2 is not going to help me, because here I'm going to have something that I don't know. It means I must say 2.5 multiplied by 2, which is not possible, right? Okay, so now I erase this. I will show you what to do. Okay, I erase this. Okay, so now, because when I just say C2, it doesn't work. It means now I must try 2 here and put 2 here, so that I have 2 carbons. Why do I put 2 and not 3? Because if I put 3, how much will I have here? I'll have 2 times I'll have if let's say I put 3, I'll have 3 times 2, which is 6, right? And then here I will be forced to put 3, which is an odd number, and we're going to have the same problems that we had. So I have to put an even number, okay, the smallest as possible. So I put 2. So 2 carbon, 2 times 2 is 4 carbons. So 2 times 2 hydrogens is 4 hydrogens. So here I put 2. So I have 2 hydrogens now. So here, how many carbons do I have? I have 4. I must put 4. Okay. So now 4 times 2 is what? Is 8. Now 8 plus 2 is 10. So I have 10 oxygens. 10 is an even number. So it means here this one can be balanced. So I can put 5 in peace. Then everything is balanced. This needs a little bit of practice if you are not familiar with balancing. So other reactions, I will do a separate videos on them. This was just on combustion. Okay, so and then where do this combustion take place actually? Remember that petrol, right? Petrol, or what you say is gasoline, right? Gasoline. It contains alkanes, right? It contains alkanes, right? And then the alkane that is present in petrol, like in huge fractions, it's octane. Okay, octane is present in petrol, or what do you say, it's gasoline. So they like to ask these questions and say give application of combustion. You just use it in combustion of octane in fuel, and then you get carbon dioxide plus water. And there's also another type of combustion of they say it's ethylene. So ethylene, so it's I think it's the alkenes. I just forgot the ethylene is a common name, so I just forgot whether it was an alkene or alkyne, but I'll look into it. So it is used as a cutting torch. You know that thing that they weld car exhaust with. That one. That's also another example of combustion reaction, ethylene. Okay, guys, that's all there is to it. I hope you guys enjoyed the video and you will learn and you will give it time. So in combustion reaction, these are the reactions that you can expect in the examination. Okay, so you must know how to balance your equations. You must know the products of a combustion reaction. You must know which to balance first and which to balance last. So you must know all the tricks there is to it. So you know combustion of alkanes, alkenes, and alkynes. Okay. Most importantly, do not forget that formula that I have shown you, and it only applies on alkanes. Alkanes only, guys. Okay. So now let's meet in other videos. Don't forget to like, share, and subscribe. If you're watching this on YouTube, like, share, and subscribe. And if you're watching this on our Facebook group of the portal, you can comment also on the link of the video. If you have any problems, you can ask on the group. In the group, you can ask, and then I will attend to it. So have a nice day, guys. Thank you.